In this entry, I will present the evidence that shows that Bell's inequalities have no consequences for understanding quantum versus classical correlations. I will also show that spin is a two-dimensional eneion. After a summary, two recent proofs are presented that show Bell's inequalities are incorrect due to an oversimplistic treatment of spin by Bell. Finally, I relate these approaches to my subquantum two-dimensional spins, which are identified as eneions. One of the proofs is by Hans Gerds in Holland, and the other by Joy Christian in England. These conclusions support my local hidden variable theory that I have presented in blogs 6, 7, and 8. I am going to state it unequivocally right at the beginning of this entry what we have all found. Bell's theorem is wrong. His famous inequalities, derived in this paper of 1964, upon which Bell's theorem is based, has finally been shown to be incorrect. Bell's inequalities certainly tell us nothing about quantum mechanics or local hidden variables. They have misled the physics community for the past 50 years. It is the end of an era. Let's recall, Bell's theorem states, no physical theory of local hidden variables can ever reproduce all the predictions of quantum mechanics. This statement is wrong. Why do people believe Bell's inequalities are correct? Much as scientists have tried to disprove Bell's theorem, no one has been able to find any errors, at least until now. In my blog 007, I discussed the EPR coincident experiments, upon which the concept of non-locality and non-local connectivity between separated EPR pairs is established. No one understands non-locality, and no one has been able to find a non-local hidden variable theory to explain the data, and no one ever will. Therefore, people are left to accept that quantum mechanics is the most fundamental theory. Hence, physicists accept that nature is random and non-local. Non-locality is supposed to be the basis for quantum teleportation. All this goes against our basic intuition. Intuition alone, however, is not enough to reject Bell's inequalities. We need a logical proof and alternate ways to explain the data. Can you understand how teleportation works? Well, I'm sorry to all you pop science fiction buffs, Scotty cannot beam you up, and no one ever will. We all have trouble understanding nature. Unless you feel comfortable with non-locality and it makes sense to you, you should keep the question open. One of my goals here is to dispel those concerns. However, today, many people state that non-locality is an example of quantum weirdness. As I mentioned in blog 006, this word has moved into physics, especially quantum information theory. It is the word that sums up the confusion of the physics community on this issue. Here is an example in the prestigious journal Nature, written by Gregor Weiss, who in 1998 produced the most definitive EPR coincident experimental data. Let us see what he says. Unsurprisingly for connoisseurs of quantum weirdness, entanglement, the mysterious holism in which the state of one quantum object is tied to the state of a second separate object, is the key to the trick. Weirdness, mysterious, tricks are words that should not be used to describe a physical phenomenon. There are no tricks in nature, only our ignorance of how nature works. Well, finally, we can banish quantum weirdness and its associated tricks to the annals of science fiction forever. This is why. Well, look at the next part of this entry, 009A, and I will describe what Hans Gerds has found.